Okay, so video 2 for lesson 7 kind of moves away from the coordinate plane and covers a couple more other topics. So here is the definition of similarity transformation and how it makes things similar. So in this question, it's saying why is PQR similar to GKJH? So the idea here is that you have two figures that are different sizes but the same shape. There is going to be a similarity transformation involving rigid motions and dilation that will result in one figure mapping onto the other. But the idea is that because you use a dilation, the original figure is similar to the new figure. The pre-image is similar to the image. So in this picture here, right, we have to perform some sort of rigid motion, dilation, to make the black triangle onto the red triangle. So the first step is the most difficult one, right? Because we have to kind of orient the black quadrilateral in the same way as the red one. So if you look here, P corresponds to G. So P is like in the top right, G is in the bottom left. So they have to move, right? And you could do that with a rotation or a reflection. Q is in the bottom right, corresponds to K, which is also in the bottom right. So notice here that we don't necessarily want Q to rotate. We want Q to kind of stay where it is in that bottom right. So I think what we're going to do is we're going to use a line of reflection. And again, this is difficult to see. I get it. But we're going to reflect this black figure across this line. And here's the line of reflection we're going to use. Okay, it's going to be this line M. And again, this is very difficult to see, but the idea is that I need this black triangle to be oriented the same way as the red one. Not on top of it, just oriented the same way. So we're actually going to do it like this. Here's going to be my line M. Like this. So that means that all of these will be reflected across it perpendicularly. So P prime is going to come here. S prime is going to go up here. Q prime is going to come up here, and R prime is going to go way up there. And here's my new figure. And you can see that it's close, right? I'm doing freehand, but it is oriented more closely, like P prime G, S prime H, R prime J, Q prime K, right? So they're oriented the same way, okay? Then so that was a reflection. Sorry, I got ahead of myself. So we were going to reflect across this line M, which we did. And again, M is just something you had to see, very difficult. I understand. 2, we're now going to translate. Now we're going to line up. We're going to line up one pair of corresponding vertices. So if we do a translation here, I want S double prime, sorry. I want S double prime to be the same as H. So that means I'm going to translate this way all of my corresponding vertices. So that one goes there. So now R prime is going to be on that, but not totally there, right? Q prime is going to be not at K, but close. P prime is not gonna be at G, but close. Right, and here's the slid figure. So now we're kind of on top of it, right? We're lined up with it, but we're not exactly on top of it. And now here's where the dilation comes into play. So now we're gonna dilate. And we're gonna do this dilation. The scale factor is going to be the new image HJ divided by this original image. Now you could use S double prime, R double prime. You could use SR. It doesn't matter. I'm going to use S double prime, R double prime, right? Because you can see. This is going to be a scale factor bigger than 1 because HJ is bigger than S double prime, R double prime, and it's going to be bigger. And your center of dilation is going to be the point S double prime, right? This point H. So everything's going to grow from there. So R triple prime will come here to J. Q triple prime will come here to K. And P triple prime will come there to G, and now your figure is on top of that figure. And it took this similarity transformation to do that, and now we know that PQRS is similar to GKJH. Notice the similarity symbol, I think we've talked about that, is the squiggle from congruence without the equals to. So that's like defining why similarity transformations provide similar figures. Okay, so there's a couple properties, right? So for any figures A, B, C that are similar, you have the reflexive property that works, you have the symmetric property that works, and you have the transitive property. So again, no big deal here. The transitive property may be sometimes if you're dealing with multiple similar figures. Actually, when we talk about similar figures and right triangles, we will use that. Okay. All right, so let's do a more applicable problem. It says, can the artist copy her sketch to cover an entire wall measuring 15 feet high by 20 feet wide so her wall mural is similar to her sketch, right? This idea of similar. Okay, so what we're going to do here is we need to kind of convert this picture, this mini picture of her sketch, onto a mural wall that is 15 by 20. So we're going to compare corresponding sides. But to do that, we need our units to be the same, right? So again, units. So we're doing feet and inches. We need to know that 1 foot is equal to 12 inches, right? So our height of 15, so this is the height. Our 15 feet, we have to multiply by 12 inches to get 180 inches. Our width of 20, we need to multiply by 12 to get 240 inches. So now we are going to compare the corresponding lengths and see if we get the same scale factors. Okay? All right. So let's compare our heights. So this height was 180 inches. I'll put that on the bottom. I'm sorry, I put that on top, right? Easier to put the bigger one on top. I apologize. So put that 180 on top. So then the 180 inches, the height, would compare to the length of 11 inches. The inches would cancel, and when you divide that, you get about 16.36, and that actually repeats. So that would be the scale factor going from the drawing to the mural. Okay. Now let's look at the widths. Okay. Again, let's put the bigger one on top. So the 240 inches on top. The width of the mural here was 14 inches. The width of the drawing. When you divide 240 by 14, you get 17.14 ... These two are not equal. Therefore, there is no way to copy this sketch to cover the entire wall where they would be similar. So we're going to say the scale factors between the heights and the widths are different. So the mural cannot be similar to our sketch. There you go. And again, it's all about consistent scale factor when you're doing similarity. Okay, last but not least, this is a state standard. They love to put this on the test, on the state test. So write a proof that any two circles are similar. So first off, you have to understand that circles are all the same shape. They're all the same shape, circular, right? So the only difference between circles is the length of their radius. The radius really defines how big the circle, right? The circumference of the circle. So the idea here is that can we use some similarity transformation to map one onto the other? That's the idea here. So write a proof. We're just going to write a simple paragraph proof. It's not even a paragraph proof. So given circle P with radius R and circle Q with radius S, we want circle P to be similar to circle Q. We want to map circle P onto circle Q. So step one, we're going to do a translation. We're going to translate so that P prime, the center of the moved circle, is going to be the same as point Q. So we're going to slide it this way, right? So that this is now P prime, and we'll have a radius of R, which is about this length, and this will be circle P prime inside circle Q. And then step two, this is just a dilation question. So now we're going to dilate circle P prime by a scale factor of, and again, we need to make this circle bigger. So we take the bigger dimension, which we only have the radiuses, so we're going to take the bigger radius S and divide it by the smaller radius R. This will be a number bigger than 1. This will make our circle grow. And again, we're going to do it about, by a scale factor of SR, about P prime. And what that's going to do is it's going to make this R radius grow. It's going to then make our circle become this big, and we will be on top of the original circle. And thus, circle P prime, circle P will be similar to circle Q. To QQ, to circle Q. Too many round objects here. And there we go. And we proved it because we have a similarity transformation that maps one onto the other. All right, very good. So again, this is kind of a weird section, but hopefully you understand and do well on the practice. All right, good luck.